This is another practice question for kinematics with integration. The question is on the particle which passes through a fixed point O at this velocity, 30 centimeters per second. It's given that its acceleration, a centimeters per cm square, is given by this expression 4t minus 16. I want to calculate the values of timing t where particle is at instantaneous rest. We should know it by now that instantaneous rest means velocity equals to 0. But did they give us velocity yet? No, they only gave us acceleration expression. So how do we get velocity from acceleration? We will need to do the integration process. So let's find velocity by integrating acceleration with respect to time. And this will be the reverse of the power rule. I will do power plus 1 divided by new power. So after your integration, don't forget to do your plus c. We can simplify this further by dividing 4 by 2. So how do we find constant c? The key hint that we haven't used yet is velocity 30 centimeters per second, which means that v equals to 30. But what will be my timing t? So note that this is another keyword, fixed point O. And at fixed point O, my t second will always be 0 because the particle starts moving at fixed point O. So we'll let t equals to 0 and v equals to 30, which means that my c will be equal to 30. So when c equals to 30, this will be my expression for v. But we're not done yet. We want to find the values of t when the particle is at instantaneous rest, which means v equals to 0. So let's equate v equals to 0. After doing some simple factorization, I will get two values for t. T equals to 3 and t equals to 5. And highlight here is that the particle can change direction at these two timings. For part 2, let's find the displacement of particle where t equals to 3. But the same thing is that do they give us displacement? S? No, they don't. But so far, we have acceleration a and also v, velocity. So I will have to use integration. Integrate velocity with respect to time to get displacement. So this will be power plus 1 divided by new power rule. Power plus 1 divided by new power. Don't forget your plus c for integration. So note that we still have a constant c to find. Are there clues given in the question? So you have to know that fixed point O is a very special keyword. Not only that t equals to 0, but at fixed point O, the distance from O is 0, which means that my displacement is also 0. So at fixed point O, s equals to 0 and t equals to 0, which means that my constant c would be 0. So now I can sub in t equals to 3 to find my displacement. And the answer for displacement would be 36 cm. Now we come to part 3, where we'll find the total distance traveled by the particle in the first 3 seconds of its motion, which means I have to take note of two timings first, t equals to 0 and t equals to 3. Are there any timings in between where the particle will be at rest? Based on part 2's answer, the particle can only change direction at t equals to 3 and t equals to 5, which does not fall between 0 and 3. So for this question, part 3, I will just need to take note of these two timings and find its displacement, which is 0 and 36 respectively, which means that the total distance traveled is 36 cm. Now for the last question, what is the distance traveled by the particle in the third second? So in the third second, what it means is that I need to find two timings, t equals to 2 and t equals to 3. So let's take note of these two timings. At t equals to 2, my displacement would be 33 1/3. And we've already found the displacement for t equals to 3, which leaves that I need to find the distance traveled, which is 36 minus 33 1/3. The answer would be 2 1/3 cm. And that's the end of this question.